Geometry students, in this lesson we're going to be looking at some practice problems related to triangles. We'll start with letters A and B, which we need to refer to the figure. It says if x equals 50, determine the measure of angle T. Well, that's easy because all three angles have to add up to 180. So for letter A, I notice I have 60 plus 50 is 110. That means that the angle measure I have left for angle T is 70 degrees, and that's the answer. All right, letter B. Determine the measure of angle T if x is 60. Well, if x is 60, that means that S and R are congruent, and that would be a 60, 60. The last angle measure is 60. This would actually be an equilateral and a regular triangle. It would be equilateral, equiangular, so it would have to be a regular triangle. Letter C. In the right triangle PQR, not pictured, the measure of one angle is 20 degrees. What is the measure of the other acute angle in PQR? Well, it's a right triangle, so one of the angles is 90 degrees. If there's a 90 degree and a 20 degree angle, that adds up to 110. That means that, once again, there's 70 degrees left to distribute to that last angle, and that's what it would be. Letter D, in a triangle ABC, determine the measure of DAB. ABC, DAB. DAB is an external angle, and an external angle is going to equal the sum of the measures of the remote interior angles, the angles that aren't touching the same vertex as the exterior angle. So it'd be 37 plus 28. 37 plus 28 is 65 degrees. That's my answer. All right, letter E. In triangle JKL, K measures 60, and the exterior angle at vertex L measures 100. Make a sketch of JKL showing the given interior and exterior angle measures. Okay, so this one, I'm actually going to have to make a sketch of a triangle, and I am going to do my best here to make a triangle that matches the criteria. Let's see, do I only have access to a right triangle? Let's see if I can access another type of triangle here, because it's not a right triangle. I wonder if I can just bend one of these triangles to my will here. Let's see, or is this always, oh, there we go. Okay, so this gives me at least a little bit of leeway what I want my triangle to look like. The only thing I can't do is I can't make an obtuse triangle with this triangle, so let's hope we don't need that. So it says that triangle JKL measures 60 degrees and the exterior angle at vertex L measures 100 degrees. Okay, so let's make that. I'm going to put some labels on here. We're going to say this is J. Then we'll make a K. We'll put K over here. And we'll put L at the bottom corner because that one should be easy for me to draw an extension from. So this is JKL. Also, the exterior angle, okay, so angle K measures 60 degrees. Let me put 60 degrees on there before I move on to the next step. So this is going to be a 60 degree angle. Okay. Let's see, I'm going to shrink the size of it a bit. Oh, I should shrink the size of the whole thing a bit. Let's make it 10-point font. There we go. Okay, so 60 degrees at the top there. And I know that my exterior angle at JKL is 100 degrees. So it looks like this, 100 degrees. And then let me make that exterior angle, which is a continuation of the side angle there. Okay, so that's what I know. Let's see, make a sketch of JKL showing the given interior and exterior angle measures. By the way, what else do I know here? Well, I know that this has to be a 40 degree angle down here because these two have to equal this one. And then my last interior angle of my triangle has to be an 80 degree measure because that brings all of my measures inside to sum up to 180. Also, it's supplementary to this 100 degree angle. So those are all the angle measures I actually know for letter E. So let's just move this up by letter E. There we go. Okay, let's move on to F. In letter F, we have to determine the measure of J in problem E. Oh, I just did that. Okay, so J is 40 degrees because it has to sum with 60 to this exterior angle measure. So the x plus 60 equals 100, x equals 40. And then let's take a look at letter G, which is our real world problem here. A planned glass pyramid structure has 4 triangular faces. The angles at the base of each face are congruent. Each of the angles at the apex of the pyramid measures 68 degrees. What are the measures of the congruent base angles? So the angles at the base of each face are congruent. That means it's an isosceles triangle. The way I would do this is 2 times that unknown side plus 68 equals 180. When I add up all 3 angles in the triangle, that has to equal 180, and these 2 angles have the same measure. All right, I'm going to subtract 68 from both sides here. That gives me 2x equals 112, okay? That means that when I divide both sides by 2, x equals 56. Let's see if that answers the question. X equals 56, that means that 2 times 56, those 56 degree angles, is 112 plus 60 is 180. Each of those angles is 56 degrees. What are the measures of the congruent angles? 56 degrees. And that is how you work these kinds of problems. Go ahead and get started on the lesson.